Hello everyone. In this video of units and dimensions, let us see what is dimensions, dimensional formula, and some examples. The nature of a physical quantity, the nature of a physical quantity is described by its dimension. Is described by its dimension. Is described by its dimension. Dimensions helps us describe nature of physical quantity, right? Let's see what are dimensions. Dimension. The dimensions of a physical quantity. Physical quantity are the powers to which the base quantities are raised. Base quantities are raised to represent that quantity. To represent that quantity. The dimensions of a physical quantity is nothing but powers to which the base quantities are raised, right? To represent that quantity. To understand what dimensions are, let's take an example, right? Example. So let's take formula density. We know that density is equals to mass upon volume. If we represent this density in terms of base quantities, we know that mass is a base quantity. That's nothing but fundamental quantity. And volume, when volume is a derived quantity, when we represent this in base quantities, we can write this as length cube, because volume is nothing but length into breadth into height. So it can be represented in terms of base quantities as length cube, right? Or we can write density as density is equals to mass into length, which is raised to the negative power of 3, right? So we can say that the dimensions of density are 1 in mass and -3 in length, right? So here the dimensions of all other physical quantities are 0, because density is represented with a formula mass upon volume. So here we are taking fundamental quantity mass and fundamental quantity length, which is raised to negative power of 3, right? So now you can understand definition easily. So dimensions of a physical quantity nothing but powers to which the base quantities are raised to represent that quantity. Here the quantity is density, right? And we are representing dimensions of density by raising powers of base quantities, in which this derived quantity density can be expressed. And now we can say Dimensions of density, here mass power is 1 and length has a power of minus 3, right? And here we can say the dimensions of all other fundamental quantities are 0 because here density is expressed in terms of mass and volume, right? Now let us take one more example to understand dimension. So second one, let's take speed. Speed is equals to distance upon time. So distance means when we express distance in base quantities, we can write this as length, right? Upon time. Time is again a base quantity. So now we can write speed as speed is equals to length into time, which is raised to a negative power of 1. So now we can say dimensions of speed, the dimensions of speed are 1 in length and minus 1 in time. I think you have understood what are dimensions. Okay, now let us see dimensional formula. What is that? Dimensional formula. Let's try to understand what is this dimensional formula. The expression which shows which shows how and how and which of the base quantities represent dimensions of physical quantity is called dimensional formula. Dimensional formula of the given physical quantity. Given physical quantity. One important point to be noted here, the physical quantity, the physical quantity that is is expressed in terms of base quantities is enclosed in square brackets. Is enclosed in square brackets. So here we will use square brackets to enclose the base quantity. This is one important thing to be noted. Okay. So what does dimensional formula shows? Dimensional formula shows how and which of the base quantities represent the dimensions of physical quantity. It's called dimensional formula of the given physical quantity, right? And always The physical quantity is expressed in terms of base quantities, which is enclosed in what? Square brackets, right? Let's see dimensional formulae of fundamental quantity in SI, right? Yeah. So let us take quantity and let's take dimensional formula. What shall we take? First, quantity and dimensional formula of that quantity. Okay. So let's start the quantity. So first is mass and its dimensional formula is capital M, that must be represented in square brackets. Next is length and its dimensional formula is capital L. Next, time, its dimensional formula is capital T. Next, strength of electric current, strength of electric current, its dimensional formula is I. Next is thermodynamic temperature, its dimensional formula is theta. Next is amount of substance, its dimensional formula is MOL. Next is luminous intensity, its dimensional formula is C and D. So these are the dimensional formulae of fundamental quantities in SI. And here one important point to be noted. What is that? Supplementary physical quantities have no dimensions. What is the important thing to be noted? Supplementary physical quantities what are supplementary physical quantities? One is plane angle and second one is solid angle. These supplementary physical quantities have no dimension. No dimension. Let's highlight these supplementary physical quantities that does not have dimensions, right? And one more important thing to be noted here. Some authors use K for thermodynamic temperature. Here we have used theta. Some books you can see even K. And A for strength of electric current. Here we have used I. Some books you can even find A for strength of electric current, right? Let's take some examples to understand dimensional formula. Okay, the first example is dimensional formula of area. Dimensional formula of area. Let's see what is the dimensional formula for area, right? So we know that area is equals to length into breadth. So we can write this as length in terms of basic quantity, length into length. So this can be written as length square. So when we represent dimensional formula for area, what can we write? Dimensional formula of area, that is equals to here m to the power 0, L to the power 2 and T to the power 0, right? The fundamental quantities which are not in this dimensional formula are what? They are simply 0, right? So m to the power 0, it's nothing but 1, and here t to the power 0 is nothing but 1, and simply dimensional formula of area is what? L square. You can even represent this as L to the power 2. Okay, dimension of area is 0 in mass because m to the power 0, right? And dimension of area is 2 in length because here power is 2. The dimension of area is 0 in time. Here we have t to the power 0. Let's take second example. Okay, example 2, dimensional formula of volume. Dimensional formula of volume. Yeah, so volume is equals to length into breadth into height. So we can write this as length cube, right? We can write dimensional formula of volume as dimensional formula of volume equals to m to the power 0, L to the power t, L to the power 3 and t to the power 0. Or this can also be written as L to the power 3. Okay, here dimensions of volume is 3 in length, dimensions of volume is 0 in mass, and the dimension of volume is 0 in time. Let's take third example. Example 3. Dimensional formula of speed, right? So speed is equals to distance upon time, right? So distance is nothing but here length upon time. This can be written as L to the power 1 upon T to the power 1, right? And finally dimensional formula can be written as dimensional formula of speed equals to m to the power 0, L to the power 1, t will come to numerator, we can write t to the power minus 1, right? So this can be written as L power 1 power minus, right? Or simply it can also be written as L to the power 1 t power minus 1. Here the dimensions of speed is 0 in mass, right? And the dimension of speed is 1 in length. The dimension of speed is minus 1 in time. Hope you have understood how to write dimensional formula for physical quantities and what is dimension. Thank you.